Today I want to do a little bit of a review over how do we solve systems of linear equations. So I've got a system of linear equations here, and I'll call this first one, I'll call this one equation 1, and the second one, I'll call that one equation 2. But when we talk about a system, what we're saying is, what point does equation 1 and equation 2 have in common? Now, let's think about this first equation, equation 1. We have x plus y equals 6. The solution to that equation forms a line. In other words, if we take all the points where if you take the x and the y together and you get a 6, what points does that involve? Well, you've got x plus y equals 6. Well, there are several. You've got 3 and 3. 3 plus 3 equals 6. You've got 4 and 2. You've got 2 and 4. Lots and lots of points. If you take the x and the y together, you add them, you get 6. 3 and 3, 4 and 2, and so forth. Now, what I want to do is I want to plot that x plus y equals 6. So I'm going to use the x and the y intercept. So if I let x be 0, I get y is equal to 6. So 1, 2, 3, 4, 5, 6 up here. Okay. So there's that point. And if I let y be 0, I'll get x is 6. So that's over here. Yeah, see, I'm just counting 1, 2, 3, 4, 5, 6. Yeah. And then I can connect those with a line. Okay, so now this line goes on and on forever, but I'm just representing, a part of it. So this line represents all the ordered pairs that if you take the x and the y, you get 6. Now, if you look at this second equation, if you look at 2x minus y equals 6, you're saying, okay, all the ordered pairs where if I take 2 times the first number and subtract the second number, do I get 6? Well, you've got 4 and 2, that would be 1, right? See, 8 minus 2, that's 6. And there are lots of them like this. There's an infinite number. And if we want to see what that looks like, we can, graph the line. So for this one, if I let x be 0, y is negative 6. So I get this point down here, 1, 2, 3, 4, 5, 6. So I get that's a point. Now remember, you just need 2 points to determine a line. And then we say, okay, well, what about the x-intercept? Well, then I let y be 0, and I get x equals 3. Yeah, so 1, 2, 3. And now I want to connect these points, and I extend it out. Now, this right here, this represents the point that both of these lines have in common. So we say that is the solution to the system of equations. And you can see here that this point is 4, 2. So both of these share that point. Now, what we generally do when we're first introduced to systems of equations is we learn a couple of methods. First, we learn the substitution method. So I'm going to do that first. So I've got 2 equations here. I've got x plus y equals 6 and 2x minus y equals 6. Okay. And what I want to do is I want to take one of these equations. Remember, this is equation 1, this is equation 2. And I want to take one of those equations and substitute it into the other. So I'm going to take equation 2 and solve for y. And if I do that, I get that y equals 2x minus 6. And if I just add y to both sides and subtract 6 from both sides, and then I put that into equation 1. So here it goes. We go x plus y equals 6. So I put in the 2x minus 6. Okay. So there it is, 2x minus 6. Put it in right there. Okay. And then I solve that rascal. So I've got 3x minus 6 equals 6. That means 3x equals 12. That means that x equals 4. Now that I know that x equals 4, I can say, well, now y is 2x minus 6, so y must be 2 times 4 minus 6. And that's 8 minus 6, which is 2. So there's our point. X is 4, and y is 2. There we go. So that's an example of solving this system with substitution. You solve one equation for one of the variables and substitute that back into the other equation. Now, I want to look at another method. And I'm going through this a little bit fast because some of you, when you were in Algebra 1, you had this. So I'm looking upon this as a review, but I can, if you let me know, I can go through it more in detail. But here we got substitution and we've got elimination. Now, if we try to solve this same thing through elimination, let's see what we get. What we can do is, now notice I've got equation 1 and I've got equation 2. What if I do this? What if I just decide to add these two equations? You know, it's like adding 6 to both sides. I add 6 and 6 over here and I get 12. Over here, y and negative y, the y's are gone. 2x and x, that's 3x. So now I've eliminated one of the variables just by adding the two. So now, dig this. I get that x is equal to 4 right away. See? This is called elimination. Now, if I've got x equals 4, you might say, well, what is y? Well, I can go back into equation 1. And I've got x plus y equals 6. So I just put in the 4. And I get that y equals 2. So there you have it. You have the solution, 4, 2. So this is an example of elimination. Now, you may have a more difficult elimination problem. For example, let's look at one of those. Let's suppose that we've got 2x plus 3y is equal to, I'm just being haphazard here, 2x plus 3y equals 11. And let's say I've got 4x minus, let's say 5y equals 2. So this might turn out to be a mess. But notice what I've got here. I've got equation 1 and I've got equation 2. Now what I want to do is I want to pick a variable to eliminate. And I've got my eye on x because notice I'm going to take equation 1 and I'm going to multiply that by negative 2. See? And let's see what I've got. I've got negative 4x. See? I'm just multiplying everything by negative 2. I've got negative 4x minus 6y equals negative 22. Okay. Now, I don't do a thing to equation 2. I've got 4x minus 5y equals 2. I'll just leave that as it is. Now let me add these. And look at this. The x's cancel. Negative 4x and positive 4x, that's gone. Now I've got a negative 11x over here. Over here I've got negative 20. So x is equal to negative 20 over negative 11. Or 20 11ths. That's what x equals. Okay? Now you can see that's kind of a messy fraction, but remember I said I was really haphazard in putting this one together. I can go back now into either equation and figure out what y is. So if I want to figure out what y is, I can go to this 2x plus 3y equals 11 and just do this. I can say, okay, 2 times 20 11ths plus 3y equals 11. I can just put that 20/11ths in there. And then I can clear out the fraction, multiply through by 11, and dig what happens. If I multiply everything by 11, I get 2 times 20, the 11's canceled, plus 3 times 11 equals 11 times 11. Whoops, kind of ran out of room. Let me just move this over a little bit. Whoops, hang on, bear with me. There we go. Equals 11 times 11. Uh-oh. There we go. Okay, 11 times 11. See, all I did was I put an 11 in the first term, the second term, and then across the equal sign. And the 11 canceled. See, when I multiplied 11 over here, it just canceled. Yeah, like that. So now let's see what we've got here. We've got 33y equals 121 minus 40. Minus 40. There we go. So y is equal to 121 minus 40 over 33. And that would be the solution for that one. And then it's just a matter of, completing the arithmetic. Okay, so that's the two main methods. And we're going to look at some other methods as we go along.